Let us look at algebra of limits of sequences. Let P sub n and Q sub n be two convergent sequences. And since they are convergent, that means they have limits. So limit as n goes to infinity of P sub n is equal to L. And let limit as n goes to infinity of Q sub n is equal to M. Limit as n goes to infinity of C times P sub n is equal to C times L, where C is a real number. Limit as n goes to infinity of P sub n plus Q sub n is equal to L plus M. Limit as n goes to infinity of P sub n minus Q sub n is equal to L minus M. Limit as n goes to infinity of P sub n times Q sub n is equal to L times M. And limit as n goes to infinity of P sub n by Q sub n is equal to L by M. Now, in case of division, we have some additional conditions. So, formally we say M not equal to 0 and there exists n in natural numbers such that Q sub n is not equal to 0 for all n greater than n. Now, the reason we are saying that Q sub n is not equal to 0 for all n greater than n is because if you remember in the previous session, we saw that the limit does not change if finitely many terms in the beginning are ignored. So what we require is that Q sub n should not be 0 for sufficiently large n. So that was just the list of algebraic operations on limits. So we have taken care of scalar multiple, addition, subtraction, multiplication, and division. Now let's look at an example. Now for that we require sequences. So let P sub n be 1 by n. So the terms are 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 and so on. We know the limit of this is 0. Now let's look at scalar multiple. Now the sequence having C times P sub n is equal to C by n, which is equal to C, C by 2, C by 3, C by 4, C by 5 and so on, where C is a real number. Now C by n can be written as C times 1 by n. So limit as n goes to infinity of C by n is equal to C times the limit as n goes to infinity of 1 by n, because C is a constant, is equal to C times 0, because the limit of 1 by n is 0, which is equal to 0. So we have limit as n goes to infinity of C times P sub n is equal to C times L. Now for the next one, we require two sequences. So we already have P sub n, let's come up with Q sub n. Now Q sub n is equal to n by n plus 1, which is equal to 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6 and so on. Now let's figure out the limit of this. So Q sub n is equal to, we have n by n plus 1. Let's take from the denominator n common out. So we have n by n times 1 plus 1 by n. So if we distribute the multiplication, we will get back n plus 1. Now this is equal to n and n cancel out and we have 1 by 1 plus 1 by n. So when n goes to infinity, what is the limit? We know for 1 by n it is 0. So limit as n goes to infinity of Q sub n is equal to 1 by 1 plus 0, which is equal to 1. And let that be m. So now we have two sequences whose limits we know. Now let's look at the second one. That is limit as n goes to infinity of p sub n plus q sub n. Now let's actually come up with the terms. We have p sub n plus q sub n. So term by term we have to add. So 1 plus 1 by 2 is 3 by 2. 1 by 2 plus 2 by 3 is 7 by 6. 1 by 3 plus 3 by 4 is 13 by 12 and so on. Now let's add the nth term. So p sub n plus q sub n is equal to 1 by n plus n by n plus 1. Combining these two, we get n square plus n plus 1 divided by n times n plus 1, which is equal to n square plus n plus 1 by n square plus n. So again, we follow the same trick that we used previously. Let's take n square common out of both numerator and denominator. So we have p sub n plus q sub n is equal to n square times 1 plus 1 by n plus 1 by n square divided by n square times 1 plus 1 by n. N square and n square cancel out, and we have 1 plus 1 by n plus 1 by n square, the whole thing divided by 1 plus 1 by n. Now, when we take the limit as n goes to infinity of p sub n plus q sub n, we get 1 plus this is 0 plus this is again 0 divided by 1 plus this is 0. So we get 1. Instead of doing all this drama, what we could have done was use the algebra of limits. So limit as n goes to infinity of p sub n plus q sub n is equal to L plus m, that is 0 plus 1 equal to 1. So instead of all this, just this one single statement would have been sufficient. Now, this is only possible if we know the limits of p sub n and q sub n. Now let's figure out p sub n minus q sub n. Let's come out with the terms. 1 minus 1 by 2 is 1 by 2. 1 by 2 minus 2 by 3 is minus 1 by 6. 1 by 3 minus 3 by 4 is minus 5 by 12. And so on. Now, using the nth terms, let's subtract. We have p sub n minus q sub n is equal to 1 by n minus n by n plus 1, which gives us n plus 1 minus n square divided by n square plus n. So again, follow using the same trick, let's take out n square from both numerator and denominator. We get n square times 1 by n plus 1 by n square minus 1, the whole thing divided by n square times 1 plus 1 by n. N square and n square cancel out, and we are left with 1 by n plus 1 by n square minus 1 divided by 1 plus 1 by n. And now we take the limit. Limit as n goes to infinity of p sub n minus q sub n is equal to, this is 0, this is 0. We have minus 1 divided by 1 plus 0. Evaluating this, we get minus 1. Instead of again doing all this, we could have used the algebra of limits. That is, limit as n goes to infinity of p sub n minus q sub n is equal to L minus m. L we know is 0. M we know is 1. So L minus m equal to 0 minus 1, which is minus 1. Now let's look at p sub n times q sub n. The terms are 1 times 1 by 2. 1 by 2 times 2 by 3 is 1 by 3. 1 by 3 times 3 by 4 is 1 by 4, and so on. Now using the nth term, let's do the multiplication. P sub n times q sub n is equal to 1 by n times n by n plus 1, which gives us 1 by n plus 1. And limit as n goes to infinity of p sub n times q sub n is equal to 0. Since as n goes to infinity, 1 by n plus 1 goes to 0. Again, alternately, by the algebra of limits, we could have just multiplied the limits themselves. So 0 times 1 is 0. Now let's look at dividing two sequences, what the limit is. Now since q sub n is not equal to 0 for all n in natural numbers and m is not equal to 0, we can proceed. Otherwise you stop here itself. So now dividing p sub n by q sub n, we get 1 by n divided by n plus 1, which gives us 1 by n times n plus 1 by n, which gives us n plus 1 by n square. So here we take n out. We get n times 1 plus 1 by n. N and one of the n's here in the denominator get cancelled. And we have 1 plus 1 by n divided by n. Now here, can you figure out what the limit will be as n goes to infinity? This 1 by n goes to 0 and this 1 by n goes to 0. So limit as n goes to infinity of p sub n by q sub n equal to 0, since as n goes to infinity, 1 by n goes to 0. And we have again 1 by n left, which goes to 0. Or alternately, we can just use the algebra of limits and say that limit as n goes to infinity of p sub n by q sub n is equal to L by m, which is equal to 0 by 1, which is 0. So here, if we say q sub n divided by p sub n, what happens to the limit? Limit as n goes to infinity of q sub n by p sub n is equal to m by L. Now this is going to be undefined, since limit as n goes to infinity of p sub n is equal to L, which is equal to 0. See, one of the conditions it is satisfying. What is that? That it is never 0. None of the terms are 0 here. But the limit itself is 0. But the limit itself is 0, which is not allowed. Hence, we say it is undefined. So that was algebra of limits. Now, if you found this session helpful, please do like, share, and subscribe. Comments, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.